In our earlier session, we developed the equation of motion and applied to solving kinetic problems directly. We then developed from this equation the principle of work and energy. This principle means that the work done by all forces is equal to the change in kinetic energy. Principle of work and energy is very useful in solving numerous problems. Now let us take another look at the equation of motion and apply a simple transformation. On the right-hand side of this equation, we have the acceleration vector. We know acceleration is the rate of change in velocity. Replacing this in Newton's second law, we get this new equation. Now we can rearrange this and integrate it. On the left-hand side, we have now an expression, force times time. We will call this term linear impulse. Because force is a vector, linear impulse is also a vector. Linear impulse measures the effect of a force during the time the force acts. On the right-hand side, we have the final and initial momentum showing the change in linear momentum from time t1 to t2. Momentum is a word that we all use in our everyday life, especially in sports. We use the word momentum to refer to a team that is on the move. When a team has tremendous momentum, it is difficult to stop the team from winning. This is true in engineering as well. It's difficult to stop a heavy truck that's going really fast. It has a large mass and high velocity. In other words, momentum is mass in motion. Thus, momentum refers to the quantity of motion that an object has. We can now read this equation as sum of all the impulses applied to the particle from time t1 to t2 is equal to change in linear momentum. Sometimes this equation is rewritten in the form where it means initial momentum at time t1 plus sum of all the impulses applied to the body during that time is equal to final momentum. As you can see, a simple transformation in Newton's second law now leads to the definition of the linear impulse and momentum principle. This principle is very useful in solving kinetic problems involving force, time, and velocity. Let us take a look at an example on how to use impulse momentum principle in solving real problems.